Greetings everyone, we will continue our field development plan of Gullfaks covering production operation and midstream operation. At the production operation we have three main stages.
The first one is production profiles and well management strategies.
The second is enhanced oil recovery techniques, and last one is evaluate operational efficiency and safety measures.
The midstream operation has two main stages. The first stage is planned for transportation and processing, which consists logistics and storage.
The second stage proposes environmental management and sustainability strategies.
Development of production profiles. A production profile for an oil field reflects the changes in oil, gas, and water production over time. For Gullfaks, this requires consideration of the major fields characteristics, including declining production rates and increasing water cut. Current condition analysis, reservoir pressure and permeability. It's essential to assess current reservoir pressure, oil saturation levels, and gas factors. Gullfaks, located in the Northern Sea, is well studied, allowing for detailed reservoir modeling. Depletion stage. As a major field, Gullfaks requires special attention to maintain reservoir pressure, achievable through water and gas injection. Production forecasting methods. Reservoir modeling is software such as Pitchell and Eclipse is used to predict oil and gas production, taking into account reservoir dynamics and well performance. Long-term forecasts. It's based on data. Several production scenarios are developed. Base scenario is maintaining the current development strategy. Optimistic scenario is implementing enhanced oil recovery (EOR) methods. Pessimistic scenario is production decline due to the worsening reservoir characteristics.
Well management strategies include Gullfaks operations over 16 wells, that including horizontal and multiracial ones. Effective management involves smart well, and the other things include sensors and the monitoring system, installing intelligent factors to measure security measures, temperature and the production rates in the real time. These systems helps us to monitor well performance and the potential injection. Remote control using smart well systems to regulate flows in multiracial wells, water cut management, water inflow isolations. Installing systems to selectively block water in water-producing zones. Redistribution of water injection, optimizing the location and the amount of injection water to enhance oil displacement. That efficiency maintains to modernization and the other technologies of oil recovery method. Well repair routine maintains including deposit, removal, hydraulic and fracturing and acid treatments, acid treatment equipments. The upgrades of replacement pumps and the pipelines to improve energy efficiency. Optimization of low productivity wells, reassessing economic viability and the other shutting down systems. Unforeseeable wells, secondary recovery, transition to other technologies such as gas lift and the surface injection.
Enhanced oil recovery techniques are crucial for maximizing production as the field ages. Here are several of the most effective EOR methods that could potentially extend the field's life and improve recovery rates. First method is gas injection. Availability of carbon dioxide or natural gas and the infrastructure to transport it to the field are important factors. Gullfaks offshore location might require pipelines or compressors for carbon dioxide injection. Second is water alternating gas injection. Optimizing the ratio of water to gas and the timing of injection cycles is critical. The field's complex geology with multiple layers requires reservoir stimulation to predict how method will perform in specific zones. And finally, third method is low salinity water flooding. This method requires detailed lab tests on core samples from Gullfaks reservoir to confirm its effectiveness, as the performance of flooding can vary significantly based on mineralogy and rock properties. In summary, these unconventional oil recovery techniques will allow us to stimulate efficient oil production, which is a very important aspect to obtain large profit from the field.
I will outline the key aspects of our field development plan, focused on efficient hydrocarbon management, safety, and sustainability. In production, we enhance well performance through advanced maintaining, recovery methods like water flooding and reductive maintenance to minimize downtime. Low emission technologies and rigorous safety protocols, including risk assignments and automation, protect both operations and environment. For midstream, we prioritize secure transportation and storage with corrosion resistance pipelines, leak detection, and advanced logistics. Storage facilities feature double containment and fire suppression systems supported by regular audits to ensure compliance. By combining innovation, safety, and sustainability, this FDP supports operational efficiency and environmental responsibility.
The Gullfaks field in the North Sea is a key oil and gas production hub operated by Equinor since 1978. It consists of 3 platforms, Gullfaks A, B, and C, connected by pipelines and equipped for processing, storage, and export. Oil export: stabilized crude oil is stored on the platforms and exported via shuttle tankers using loading buoys. Gas export: natural gas is transported through the stat pipe system to the coastal processing plant for international export.
Pipeline network subsea pipelines connect Gullfaks to neighboring fields like Gullfaks, Soar, and Rimfaks, enabling centralized processing and storage. Platforms A and C handle oil stabilization and water removal, while C also processes gas to extract valuable liquids. Storage tanks in the platform bases allow flexibility in export logistics. This integrated system ensures efficient transportation and processing of a hydrocarbon from Gullfaks and surrounding fields.
Let's talk about environmental management and sustainability strategies. First of all is implementation of carbon capture and storage CCS technologies. CCS systems can be employed to capture CO2 emissions generated during oil processing or transportation and store it in underground reservoirs, such as depleted oil or gas fields. On the Gullfaks platform, CCS can be integrated to capture CO2 emissions from fuel combustion in compressors and pumps. Norway is already a global leader in CCS technologies, providing access to local expertise. For instance, the Sleipner platform has been using CCS for over 20 years, successfully reducing greenhouse gas emissions. Second is installation of oil spill risk monitoring and management systems. Equip the Gullfaks platform and vessels with rapid response tools such as barrels, skimmers, and sorbents. Install intelligent sensors to detect corrosion, cracks, or leaks in real time. Third is eco-friendly logistics. Optimize oil transportation routes to minimize distances traveled. Utilize low emissions or LNG-powered vessels. For Gullfaks, use double-hull tankers with reduced fuel consumption and select marine routes that minimize impacts on sensitive ecosystems.